And that's when the whole customer service chatbot went down. I'm talking thousands of frustrated users, Priya. Thousands. All because of a single, badly chunked PDF.
A single PDF took down the whole thing? That sounds dramatic. Was it like the size of the Library of Congress?
Not quite, but it was a critical product manual for their flagship software. The REG system just choked on it. Couldn't retrieve the right information, hallucinated answers, the whole 9 yards. It was a mess. This is why we need to talk about production RAG. It's not just about getting a demo working.
Okay, you've got my attention. So we're talking about moving beyond the Hello World RAG applications and building something that can actually handle real-world data and user load. What breaks when you don't do this right?
Everything breaks. Think about it. Inaccurate answers erode user trust faster than you can say artificial intelligence. Slow retrieval times lead to abandoned sessions and frustrated customers. Unscalable systems crumble under peak loads, costing you money and reputation. Imagine a Netflix recommendation engine powered by RAG that suddenly starts suggesting documentaries to someone who only watches action movies because it can't handle the user load.
Ouch. So what are the core pillars we need to nail to build RAG systems that don't collapse under pressure? Where do we even start?
It all boils down to 3 key areas: retrieval strategies, chunking techniques, and context management. Let's start with retrieval. It's the foundation of everything. If you can't find the right information, the rest is pointless.
Makes sense. So what's the most common mistake people make with retrieval?
Assuming that simple keyword search is enough. That might work for toy examples, but in the real world, you need semantic search. You need to understand the meaning of the query and the documents, not just look for matching words. Think about Uber. They use semantic search extensively to match riders with drivers, even when the rider doesn't use the exact address in their request. Take me to that coffee shop near the park. Needs to be understood, not literally matched.
Okay, semantic search. But how do you actually do semantic search at scale? What algorithms or techniques are essential?
Vector embeddings are your best friend here. You encode both the query and the documents into vector representations, and then you use cosine similarity or other distance metrics to find the closest matches. This allows you to retrieve documents that are semantically similar, even if they don't share any keywords.
So, like representing words and sentences as points in a high-dimensional space and finding the points that are close together.
Exactly. And the crazy part is, those vector embeddings capture relationships you wouldn't even think about explicitly programming. For example, king and queen might be close together in the embedding space, even though they don't share many letters.
Okay, embeddings are cool, but doesn't that mean you need to constantly re-embed your documents as they change? That sounds expensive.
It can be. That's where incremental indexing comes in. Instead of re-embedding the entire corpus every time, you only embed the new or updated documents. You need a robust system for tracking changes and keeping your index up to date. Cloudflare, for example, deals with massive amounts of log data and uses incremental indexing to analyze security threats in real time without constantly reprocessing everything.
Right, makes sense. Okay, retrieval is step 1. What about chunking? You mentioned a disastrous PDF earlier.
Chunking. This is where things get really interesting. Chunking is the process of dividing your documents into smaller pieces that can be processed by the RAG system. The naive approach is just to split the document into fixed-sized chunks, but that often leads to fragmented information and poor retrieval accuracy.
So what's the alternative? How do you decide where to break up the text?
You need to be smart about it. Consider semantic chunking. This involves breaking up the document along natural boundaries, such as paragraphs, sections, or even sentences. The goal is to keep related information together in the same chunk. Think about how Google indexes web pages. They don't just chop them up randomly. They try to identify logical sections and treat them as separate units.
Okay, but what if a single paragraph is too long to fit into the context window of the language model?
That's a great question. You might need to use a combination of techniques. You could start with semantic chunking, and then, if a chunk is still too large, break it up further using a fixed size approach. But here's the kicker. Consider adding metadata to your chunks.
Metadata? Like what kind?
Things like the document title, the section heading, the page number, and even a summary of the chunk's content. This metadata can help the RAG system understand the context of the chunk and improve retrieval accuracy. Amazon, for example, uses extensive metadata to organize and search its product catalog. Imagine trying to find a specific book without knowing the author, title, or genre.
Okay, metadata is key. But doesn't adding more metadata increase the size of the index? And doesn't that slow things down?
It can, but you can optimize it. You can use techniques like dimensionality reduction to reduce the size of the metadata vectors. You can also use caching to store frequently accessed metadata in memory. It's all about finding the right balance between accuracy and performance.
All right, retrieval and chunking, that leaves us with context management. What's the biggest challenge here?
The biggest challenge is dealing with the limited context window of language models. You can't just stuff the entire document into the prompt. You need to be selective about which information you include. And here's where it gets interesting. Most engineers think about maximizing the amount of context, but what you really need to do is maximize the relevance of the context.
Relevance, not volume. So how do you determine what's relevant?
You need to use a combination of techniques, such as query expansion, context filtering, and re-ranking. Query expansion involves adding related terms to the user's query to broaden the search. Context filtering involves removing irrelevant chunks from the context window, and re-ranking involves sorting the chunks by their relevance to the query, putting the most important information at the top. Can you give me a concrete example of how this works in practice?
Sure. Imagine you're building a chatbot for a medical website. A user asks, what are the side effects of this medication? You could use query expansion to add related terms like adverse reactions, drug interactions, and contraindications. Then you could use context filtering to remove chunks that are not related to the specific medication the user is asking about. Finally, you could use re-ranking to sort the chunks by their relevance to the user's query, putting the most important information at the top.
So it's not just about throwing everything at the language model and hoping for the best. It's about carefully curating the context to provide the most relevant information.
Exactly. And one more thing, think about conversational memory. RAG systems aren't just about answering single questions. They're about engaging in conversations. You need to maintain a history of the conversation so the system can understand the context of subsequent questions.
Okay, that makes sense. So what are the practical takeaways for a software engineer who wants to build a production-ready RAG system? What should they do differently after listening to this?
First, stop relying on keyword search. Embrace semantic search and vector embeddings. Think of it like upgrading from a flip phone to a smartphone. You wouldn't build a modern app on outdated tech, would you? Second, get serious about chunking. Don't just chop your documents into random pieces. Use semantic chunking and metadata to preserve context. Think of it like organizing your closet. You wouldn't just throw everything in a pile, would you? You'd group similar items together.
And third?
Third, prioritize relevance over volume in your context management. Focus on curating the most important information for the language model. Remember, it's not about how much you say, it's about what you say. Think of it like writing a tweet. You only have a limited number of characters, so you need to make every word count.
Great actionable insights. So retrieval, chunking, context, the trifecta of production RAG.
Absolutely. Master those three, and you'll be building RAG systems that not only work, but also scale, perform, and deliver real value. Because in the world of RAG, context isn't just king, it's the whole kingdom.